Okay, so does everybody see this question in their bell work packet? This first one is already ready to graph, so you can go ahead and graph this out. So this first one is already set. The slope is -2 over 1. The y-intercept is 4. Go ahead and graph that. Lex, do you mind putting away your device, please? Can we all take out our earbuds and put our phones away? Thank you so much. So you're going to put a point at 4 on the y-axis. And then the slope is -2, so you're going to go down 2 to the right 1, down 2 to the right 1. And draw your line. Now, as for me, on this iPad, it's a little hard to get a perfect straight line. But you do, if you have a straight edge, you want to try to use it. And that takes care of the first equation. But the second equation, this is not ready. Now, we could graph it using the x and y intercepts, but I want you to practice rewriting it in slope-intercept form. So rewrite in slope-intercept, which means you're going to solve it for y. So you're going to take this -x, move it across the equal sign. And whenever you do that, it changes sign. So it's going to become a positive x. And then you're going to divide everything by 3. But keep in mind that there is an invisible 1 that's in front of the x right now. So that equation becomes y equals 1/3 x minus 3. Your slope is 1 over 3, and the y-intercept is -3. Go ahead and graph that. So we're going to start our line. B is where we begin. And then we go up 1 to the right 3. Up 1 to the right 3. Draw your line. Now with this method, you want to make sure your line is perfectly straight. But the solution is right here. So there's 3 different methods that you can do to solve a system. And one of them is substitution, and that is also a great method. So graphing, substitution, and today we're going to do elimination. Yes, Kenna?
So if it doesn't specify on the question, what way to solve it, does you do?
Yep, you sure can. Absolutely. So the test, I think the test is pretty specific. It'll say use substitution or use graphing or use elimination. But for this question, the bell work, we could have used any of the methods. So just to practice graphing though, we did graphing and we got our solution And that solution is located at 3, x is 3, and y is negative 2. So for those of you who use a different method, did you still get that answer? Did you get 3, negative 2 if you use a different method? All right, so let's go to page, I believe, page 109. Yes, page 109. And let's talk about the third method, which is elimination. This way is the way I prefer because I think it's the easier of the three, personally. Okay, so elimination. So I am going to do this a little differently than the way it is described in the book. So one question you're going to have to do off on the side. But for elimination, the goal is to have opposites. So we're going to have to multiply to get opposites. We are not going to try to get equal. Let's cross that out. Okay. We want to use opposites. Okay. It's a lot easier if we can do opposite terms instead of equal terms. So one of the examples I'm going to do differently than it is described in the book. So let's look at example 4. So for example 4 on page 109, okay, it says multiply one or both equations by a number to get two opposite. And they told us step number 1 is to multiply the equation. So what they chose to do was multiply equation 2 by negative 1. So what they did, and there's nothing wrong with this, they chose to multiply this equation by negative 1. And why are we doing that? Because what are we noticing about these two numbers? They're the same, but we want opposites. So how do you change it to the opposite sign? You multiply it by negative 1. So do you see where it says multiply equation 2 by negative 1 to get the opposite terms, negative 9y and 9y? So what do you get when you multiply this by negative 1? What would your new equation change to? Perfect. Okay, so that's your new equation. So in your book where it has that big blue arrow, it says multiply by negative 1. That's what you're going to put. That's your new equation. Okay, so the book, unfortunately, it actually just worked it out for you. So we have the negative 2x minus 9y equals negative 25. So then they added that to the new equation. Oh, I wrote the first one wrong. Sorry, let me fix that. That's actually a negative 25. All right, so this black equation, that's the original equation 1. And the equation that I have written in red, that's my new equation 2. So now what they want you to do is add it together. So go ahead and add together. Fill in the blanks. Because when you have opposites, something is going to eliminate. That's why it's called elimination. That's why I like to have opposites. Because if it's opposites, that's how they eliminate. They don't eliminate if it's the same. So we're going to cross that out, and when we add together, we get, what's negative 2x plus 4x? 2x, so put a 2 on that blank. That's going to equal negative 25 plus 23, which is negative 2. Divide both sides by 2, and what does x equal? X equals negative 1. Good job. So now we're ready to do step 3. So again, they did it for you. They told you the answer. but we'll work through it together so you can understand why that's the answer. So they chose to use equation 2. Now you could use equation 1 also and get the same result. So that's what I want to make sure you understand when you're doing your homework and when you do your test, is that you can use equation 1 or 2. Okay, so they used equation 2, so we're going to roll with it. So the equation is negative 4x minus 9y, and I'm just rewriting what's in your book just to make sure you understand why. So negative 4, and then they substituted in the negative 1. So that would be a positive 4. So now, what goes on that next blank? So when you subtract the 4 from both sides, what do you get? So you're subtracting 4, not negative 19. No. Negative 27, right? So you should have negative 9y equals negative 27. So in your book, this is what you're filling in the blank. You're filling in your negative 9 and your negative 27. Excuse me. And they already told you the answer is 3. So if you divide negative 27 by negative 9, you get y equals 3. And that would be your solution. So at the very bottom, it says the solution to the system is, what is the solution to the system? Negative 1, positive 3. Go ahead and fill in that blank. Okay, so now let's look at example 5. Now, example 5, I am going to do differently. So what I want you to do, you see how you have all that blank space off to the left? I want you to just write it off to the side. Now, I'm not saying that I'm smarter than the authors of this book, but I am going to say I have 15 years teaching children, and it's easier to do opposites and not the same, okay? So we're not going to try to fill in the blank. We're going to just do it off to the side, okay? So what we're going to do, because in the book, it has you multiplying the first one by 2 and the second one, no, it has you multiplying the first one by 3 and the second one by 2. That's not what I want to do, okay? What I want to do, I want you to multiply the first one by 3. But the second one, I want you to multiply it by a negative 2. Okay, and the reason why is because I want opposites. I don't want the same. So I don't want to do that. We want opposites. Because 3 times 2 would make this a 6x, and 3 times negative 2 would make that a negative 6x. The book is trying to show you another way. But let's not fix what's not broke. Let's stick with the opposite. Okay? So off to the side, I want you to multiply this top equation by 3. The entire equation, multiply it by 3. And the second equation, I want you to multiply it by negative 2. I want you to keep in mind that when we do elimination, we want opposites, not the same. So our equation changes to 6x plus 15y equals what? 3. And now our second equation, we have negative 2 times 3, which is a negative 6x. Negative 2 times negative 4 would be a positive 8y. And a negative 2 times a negative 10 is a positive 20. So the reason why I wanted us to have opposites is because if I multiply this by a positive 2, then that wouldn't eliminate. But now, you see how these are opposite signs? When we add them, it cancels out. So let's go ahead and solve that equation for y. You're going to add straight down and solve it for y. So you should get y equals 1. Who got y equals 1? Okay, good. So now we're going to find x. So when we find x, they use equation 1. You can use equation 1 or 2 to find x, but I will probably use equation 1 too. So I'm going to use equation 1. So let's go ahead and find x. So to find x, I'm going to take equation 1. And then instead of y, because I just solved for y, I know y is 1, put a 1 right there. And solve that for x. So 2x plus 5 equals 1. Subtract 5 from both sides. (2x) equals -4. Divide by 2. And you should get x equals -2. Who got x equals -2? All right. So now it says at the bottom, the solution of the system is, what would be your solution? Would it be 1, -2, or is it -2, 1? -2, 1. Good job. All right, our last question for today is example 6. So let's look at example 6 together. So now for example 6, this is showing where it's, what does it look like when you don't have a solution? They already worked it out for you, but I'm going to explain a little bit in a little bit more detail what they did. So they said they multiplied equation 2 by -3. Why did they multiply this by -3? Oh, wow, you fancy. She said 7 is a third of 21. I wasn't even going to get all fancy, but I was just going to say because 7 times 3 is 21, but okay. We'll do it that, because 7 is a third, okay, of 21. So that is true. That is why. So what they're trying to do is get these to become opposite. So when you multiply it by -3, so the first equation stayed the same. And the second equation, we multiplied it. And look at what happens. So what we're trying to do is eliminate one variable, but for this one, they both eliminated. This canceled out, and so did that. So we're left with, on this side, 0 plus 0 equals 8. Or 0 equals 8. But is that true? Is $0 the same as $8? It's not the same. This is false. And just like Friday, whenever you have something that is false, when x and y cancel out, the system has no solution. So a false statement means it's no solution. The lines are parallel. Okay, so next week is our second test of the semester. This is homework 12. We're up to homework 12. Please check to see if that is your papers in the front. Is somebody in this class? I don't know who it is. 8 through 14 must be turned in by the 20th to get credit.